Welcome to Feline Puzzles Press Puzzle Tutorial Collection. Today we'll take a look at Skyscrapers puzzles. A skyscrapers puzzle consists of a grid with some clues along its sides. Your goal is to place a skyscraper in each square, with a height between 1 and n, where n is the size of the grid, so that no two skyscrapers in a row or column have the same number of floors. The number of visible skyscrapers, as viewed from the direction of each clue, is equal to the value of the clue. Higher skyscrapers block the view of lower skyscrapers located behind them. Let's look at that in a bit more detail. In this case, viewing from the direction of the blue arrow, we can only see a single skyscraper, the one closest to the edge. Since it's also the highest one in the row, it obscures the three remaining skyscrapers. This arrow can see two skyscrapers. The one closest to the edge, that has a height of 3, and the one behind it, that has a height of 4, so it's not obscured. Yet again, the skyscraper that has a height of 4 is the highest in the row, so it obscures everything located behind it. In this case, we can see 3 skyscrapers from the point of view of the arrow. The first one, on the edge, is always visible. The second one has a height of 3, so it's not obscured. The third one is lower than the second one, so it is obscured, and then the final one is visible again. Finally, in this case, looking from the point of view of the arrow, we can see the edge skyscraper that has a height of 2 and obscures the lower skyscraper behind it. Then the skyscraper of height 4 is visible behind the one of height 2, and, in turn, obscures the skyscraper of height 3. As you can see, sometimes the puzzles don't have a complete set of edge numbers, and as a general rule, more complex puzzles will have bigger grids and less edge numbers. And now let's try to solve this sample puzzle. So, where do we start? First of all, we have 3 values that suggest only one skyscraper is visible from these points. This means each of these values is looking at the highest skyscraper in the respective row or column. Considering our grid has a size of 5, each of these skyscrapers must have a height of 5. That was easy, but what next? Well, we also know only one 5 can be present in each row and column of the grid. We have placed 3 of them, so we have 2 left, and 4 possible cells where they can be located. However, we can also tell one of these locations would not work. Imagine, we place a 5 in this highlighted cell and try to look at it from the bottom. We would be able to see the 5. We would also be able to see the number in front of it, as 5 is the biggest number in the column, so there is no other number that can obscure it. But then, the 5 would obscure everything behind it, and we would be stuck with only 2 visible skyscrapers, while the clue tells us we should be able to see 3 of them. This means we can't place a 5 in this specific cells, and instead of 4 cells to place the 2 missing 5s, we now only have 3, so the placement that allows one and only one 5 in every row and column must look like this. Now that the 5s are placed, let's try to see what we can tell about the locations of the second tallest skyscraper, the one of height 4. And we'll start with trying to tell where we can place the skyscraper of height 4 in the last row. Looking from the bottom, we have 3 columns that tell us 3 skyscrapers are visible. A 4 in the bottom row would mean that from each of these points, we could see the 5 behind that 4, but nothing else, which clearly doesn't total to 3 skyscrapers. So, these 3 edge cells cannot hold a 4, conveniently leaving us with a single empty cell in the row. Now let's take a look at this edge 2 in the third column. Looking from the top, we can tell it will be able to see the 5, but not the 4 behind it. And since only 2 skyscrapers are visible from this point, we can tell the value in the highlighted cell must be able to obscure the 2 cells behind it. This means it must contain a 3. Knowing this, we can now place a 4 in the top row. Thing is, if we look from the right, placing a 4 in either of the highlighted cells would obscure both the 3 and the cell behind it. So, at best, we would have 3 visible skyscrapers including the 5 in row 1. So yet again, we can eliminate 2 cells in the row from containing a 4, leaving us with a single cell that still allows it. Proceeding to row 2, we can look from the left this time. We know columns 2 and 3 already have 4s, and a value can only be placed in a column once. Additionally, placing a 4 in the edge cell would obscure everything behind it except for the 5, and we know 4 values should be visible from this point. So, yet again, we are left with a single cell that can still contain a 4. With 3 4s placed, we have 2 more to go and 4 possible locations to place them. Sadly, we don't know enough to eliminate either of these locations, so let's try to find something else we can do. For example, we can complete row 1. The 3 values we already have placed are all visible, because the 2 values still missing in the row are 1 and 2. To have a total of 4 visible values, one of the values in the row needs to be obscured. We know it can't be the edge value, so it must be the one in column 4. This means that the value in the last column must obscure the one behind it, so it must be a 2 obscuring a 1. And now let's take a look at row 4 and our options for placing a 1 in this row. First of all, we can't place a 1 in the first column, because it would not be able to obscure the cell behind it and we would end up with 3 visible skyscrapers, and we know we should have 2. We also can't place a 1 in the second column, but for a totally opposite reason. A 1 in the 4th row would be obscured by pretty much any value in the 5th row, so we would end up with 2 visible skyscrapers, and we need 3. Finally, we can't place 1 in the 4th column either, because it already has 1. To conclude, out of the 4 cells in row 4 that still don't have a value, we know 3 of them can't hold a 1. This means the 1 in row 4 needs to be located in the last column. Now we can go back to our 2 missing 4s, because we have just eliminated one of the 4 possible positions for them and are left with a single placement that ensures each row and column has 1 and only 1 4. At this point the last column is left with a single empty cell and a quick check tells us that it's missing the value 3, meaning it must contain a 3. And now we can complete the last row. Out of the 3 values we already have placed, 2 will remain visible, so to have 3 total visible values, the value in column 2 must be obscured. This means column 1 folds a 2, while column 2 holds a 1. Now let's look at the second row and our options to place a 3 in there. We clearly can't put a 3 in the first column, as it would obscure the 2 values behind it and we need a total of 4 visible values. We also can't put a 3 in column 3, because it already has 1. This means that out of the 3 empty cells in row 2, 2 of them can't hold a 3, meaning the 3 needs to be located in column 2. Column 2 is now left with a single empty cell, and as we can see, it's missing the value 2. After that is placed, we are left with a single empty cell in row 4, that happens to be missing a 3. Placing this 3 leaves us with a single empty cell in column 4 that is missing a 2. At this point our table has 4 cells containing the value 2 and 1 possible placement that won't conflict with either of them. After we place the remaining 2, row 2 is left with a single empty cell and is still missing a 1. Placing that leaves us with a single empty cell in column 1 that must contain an 3, and, finally, a single empty cell in column 3, that must contain a 1. There, the puzzle is solved. If you have any question or would like to see a tutorial for a specific puzzle type, feel free to reach to us. See you next time in the next tutorial.